notes on two-step equations. These should be fairly simple. There might be a couple of things. Today, there's only about one thing new, and then tomorrow we're going to add one more thing. Yes, sir. What? A Sharpie? Um, we'll do that after instruction, okay? That way I can get through this. All right. Your work today has room enough where you're going to be able to do your work on the worksheet. Tomorrow I'm going to ask that you do work on a separate piece of paper, and we'll do that when we do the notes too. Remember that there's always paper, and I have actually moved it. It is in the big tub, in the big stacks there of boxes. It's in the top shelf down. So if you ever need paper, it's there. It's available for you, okay? I'm not sitting here going, did you take 1 or did you take 5? I don't care. Okay, I keep it stocked for you. All right. 2x plus 5 equals 13. This should be pretty much a no-brainer, hopefully for you all. 2x plus 5 equals 13. First thing I need to do is get my constants and my variables on the same side. So what is the first thing I need to do? I need to get this 5 away, so what makes it a 0 pair? Subtract 5, correct. So if I do one thing on the equal sign, I have to do it to the other side. That is called the property of equality, okay? And I can do anything I want to one side as long as I do it to the other side. If I wanted to, for some off-the-wall reason that doesn't make any sense at all, I could take and I could multiply both sides of this equation by 52, okay? As long as I was doing on one side and I do it on the other side, it does not change the equality of the equation, and that's what you have to make sure you maintain, okay? So, with that being said, I subtract 5, that just cancels that out. I bring down my 2x is equal to 13, take away 5 is 8. Last step, this means it's multiplying. The opposite operation of multiplying, or the inverse operation, is what? Divide by 2, and I end up with x is equal to 4. And I don't think I've given you challenging numbers. I've tried to make it intentionally with easy numbers because I don't want this to be about doing calculation. It's calculations that you should know. I want this to be about, do you know the process? Okay? All right, this says 4x minus 3 equals 9. I just want to show you an example because sometimes you're going to see algebraic equations like this. Is that any different? Everybody agree it's not, correct? If you're given something like this and that throws you, okay, what I'm trying to say is if that bothers you not to have the variable on the left side, all you have to do is take and rewrite it as 4x minus 3 is equal to 9. You can rewrite it as long as you keep your 4x positive, and this is your negative 3, or you subtract 3, and your 9 positive. As long as you keep those positive and negatives the same thing, you can flip the sides if that's what makes you more comfortable. I have students all the time who do not like to work an equation like this, although it does not matter, okay? It's going to work the same exact way. They'll always turn it and flip it to look like this. So it's whatever you're comfortable with, I'm good with, okay? It's just your process. So first thing I need to do is get this 3 over with this 9. When I teach equations, and I know you guys know this now, but I always talk about gangs, okay? I call the constants the crips and the variables the bloods. And you see these are railroad tracks, and you can't have if you have a crip and a blood on the same side of the street, what's going to happen? They're going to kill each other, right? So these little crips need to get over with their friends over here that are crips, okay? And they need to stay on their side of their turf, okay? It's just something that, sometimes makes, for some students, it makes it click, but I know you guys already have this down, so if I ever do that, just realize it's just me regressing, okay? So I'm going to add 3 to both sides. And that cancels out. Please don't write 0 here, okay? Just mark it off. Bring down your 4x is equal to 9 plus 3, which is 12. Divide by 4, and I get x is equal to 3. Now, if you are extraordinary, okay, and I would like you to show your steps, all right? Just because as things go, it'll get a little more complicated than this, and it helps you keep things straight. Do I need to write this step for myself? Probably not, but the first time I don't is the time I make a mistake. And that's what I find for myself, especially working equations. As soon as I start skipping steps, I make mistakes, okay? Here we go. We've got negative. Now, what did I tell you to do if you don't have a number in front of a variable? All right, so let's write it just so we remember it. Plus 5 is equal to 1. These are really easy. I know they're easy. So we're going to do what? Subtract 5. That cancels that. I end up with negative 1x is equal to what? Is it 4? Negative 4. Now, can I leave it like that? No. Why? What?
You haven't done your, you haven't divided by your.
Okay. In other words, your variable can never be left negative. Okay? So, even though it's a 1x, all right, that's great. I know what 1x equals, but your variable can never be left negative. So, how do I get rid of that? How do I deal with this right here? There's 2 different ways I could do it.
Add 1 to it?
No. That's multiplication. That doesn't take care of it. What? Divide it by what? If I divide by 1, negative 1 divided by 1 gives me what?
Well, negative 1 divided by negative.
So I could divide it by negative 1, which means then I divide this side by negative 1. Those make 1, right? Negative 1 divided by 1 gives me 1, correct? Positive 1. Negative 4 divided by negative 4 gives me how much? I'm sorry, negative 1. What am I doing? Heaven forbid, I'm already not thinking. All right, negative 4 divided by negative 1 gives me what? Positive 4. The other alternative is I could multiply it by negative 1, both sides, as long as I multiplied both sides by negative 1. Because it is a negative 1, it's really simple. Negative 1 times negative 1 gives me a positive 1. And if I multiply negative 4 times negative 1, I would get what? A positive 4. Okay? So either way would be correct at this point when you have a negative 1. It may not work when you have a negative 5. Okay? If I had a negative 5x, it wouldn't work. I'd need to divide by negative 5. So, all right. Have you done these? Yes, no, maybe so. Do we know what it means when we have a number next to parentheses? Multiply. So we need to use the distributive property of multiplication, okay? So what we need to do is we need to take this 3 and we need to multiply it times x, and what do we get? 3x. Then we have to take this 3 and multiply it times a positive 2, and what do we get? Plus 6, okay, is equal to 15. Now we're just back to where we were before with the equation. Pretty simple, right? Okay, so subtract 6 from both sides, and I end up with 3x is equal to 9. Divide by 3, and I get x is equal to 3. And if you'll box your answers on your paper, I will be very happy. Okay? All right? Piece of cake, right? So, next one's the same thing. I've got 2 times 2x minus 1 is equal to 10. So what is 2 times 2x? 4x. So in other words, you're multiplying what's outside the parentheses by each term, okay, of this right here, each term. So 2 times 2x, then 2 times negative 1, which is negative 2, is equal to 10. Now I'm just a straight two-step equation. Add 2, and I end up with 4x is equal to 12. Divide by 4, and I know that x is equal to 3. Any problems? Yes, no, maybe so? No? We're good? All right.